Okay, in this slow scroll through this published paper on GitHub, looking at a Jupyter notebook through NB Viewer, is this slow enough? It's open for you to strip out my audio track and add your own, explain it in your own words, or just put a music track or something, right? So I'm passing on this about Quadray coordinates. This is in Wikipedia. You can look it up. And I'm using Python, an assortment of tools. Especially, I want to draw attention to SymPy as a useful way to gain access to super high precision numbers, way beyond what the floating point type will do for you. It's kind of like long integers are to integers as these long decimals are to ordinary floating points. Now, you could, in theory, use the decimal module inside of the Python standard library, but this doesn't. SymPy has its own, I think it wraps Gimpy, GMPY, maybe. How exactly SymPy gets its long format integers, I'm not sure. So what we do in this is, as you see right here, I'm getting the 12 combinations of two ones, a 2, and a 0. I just get all the unique permutations of that. And it ends up in quadray coordinates representing these 12 orange arrows to the corners of the yellow cube octahedron, which I label those vertices, right? O through Z per an A through Z arrangement that you'll see in Wikipedia under quadray coordinates. So I'm taking the diagram from there and I'm using its labeling system, the Wikipedia one. And I'm saying, okay, so let's just find those corners that are 60, 60, 60 degrees. In other words, let's take all permutations now of those 12 vectors. Let's take them in groups of 3 and just keep the ones that are clearly the tip of a regular tetrahedron. So we have a regular tetrahedron, which means 3 vectors starting from the corner, any corner, and going a certain distance. And we want to show that those 3 distances intermultiplied to give a volume that equals their product, which is not usually true in ordinary XYZ math, but this is IVM math. So we get to very, very high precision, 50 decimal places. It's still just 20. In other words, we're not talking about approximations here. We're talking about those 3 vectors, A times B times C equals product ABC, but represented in terms of unit tetravolumes, not unit cubes. More in this YouTube. You can embed YouTubes in Jupyter notebooks, and that's the story. Feel free to use this yourself.